Okay, the rational root theorem gave us a list of possible rational roots, and it gave us the ability to find some rational roots. But now we've got an issue. How do we find the irrational ones? And let's go back and remind you for some problems that this year or this course that we've actually found some irrational zeros. Let's go back and solve these. Let's find the zeros of these functions. So the first one, a reminder that you can factor. Um, this is quadratic form. That'd be an x squared times an x squared, adds, multiplies would be a -6 and a -3. However, this doesn't factor again. So you could stop here and say that x squared minus 6 is equal to 0 and x squared minus 3 is equal to 0 and solve from there. Move the 6 over, gives you x squared is equal to 6. Now when you get rid of that square by square rooting. Don't forget to do plus or minus the square root of 6. Now those two zeros there are irrational. Square root of 6 is not a perfect square root, so we're not really sure what it is unless we have a calculator. Move the 3 over here, and you see the exact same thing. X is equal to plus and minus the square root of 3, which is also two irrational. So there, the four roots that we just found were four irrational roots. Let's do a couple more warm-ups. Same thing here. We can use our slip and slide. That's going to be x to the fourth minus 33 x to the second plus 32. Factoring that, because it's of quadratic form, would be x squared and x squared. Adds, multiplies would be a -32 and a -1. We moved the 4, so we now had to divide by it. I nearly forgot. So that would leave you with an x squared minus 8 here. This does not divide or reduce, so slide the 4 back to the front. And here is your new function. Again, we set it equal to 0 so that we can find our roots. Now, each of these, now this will factor again, and you could do it either way. So let's go ahead and factor that one more time. X squared minus 8 times, that's difference of squares. Difference of squares factored into conjugates. 2x times itself gives you 4x squared, and 1 times itself gives you 1. So therefore, my roots now, since this will not factor again, I've got to stop where I'm at, and I've got to set it equal to 0. And then set each of these equal to 0, 2x plus 1, and 2x minus 1. And my answers will be, when I move my 8 over and take the square root, that's going to be x is equal to plus and minus the square root of 8, which we can simplify. That's going to be plus and minus 2 root 2. There's 2 of our roots, and our other 2 roots are going to be x is -1/2 and x is +1/2, just to show you that, hey, these 2 roots are rational. That's like what we found in our last lesson. However, you might have some irrationals, 2 root 2, I don't know the square root of 2, mixed in with your rationals. Another method we can use to find these irrationals is factoring by grouping. Might still have to use it. Pull an x squared out of the first group. We're setting this equal to 0 to find our zeros. You're left with 2x plus 5. Pull a -12 out of our second group, and you're left with 2x plus 5. Factor 2x plus 5 out of both groups, and you're left with an x squared minus, and that should have been, there's no x here. That should have been x squared minus 12. Now from there, this will not factor again. It's not difference of squares, so not a lot we can do with it. So set each factor equal to 0. And you see here, when you set this equal to 0, you get -5/2. There's one of your roots, which is rational. However, when you move the 12 over and you plus and minus square root over here, it gives you plus and minus root 12, which we don't know the square root of. That is an irrational root. So you have 2 irrationals and a rational there. Let's work one more. And again, this is another factor by grouping. Set it equal to 0 to find our roots. Let's factor out a 3x squared out of our first group, leaves you with x minus 5. Let's factor a -4 out of our second group, which leaves us with x minus 5. Factor in x minus 5 out of both groups, leaves you with a 3x squared minus 4. Okay. Set each of these. This is not factorable. If the 3 was not there, sure, it'd be difference of squares, but it is there. So set each of these again equal to 0. X minus 5 equals 0, or 3x squared minus 4 equals 0. Here, x is equal to 5. You have a rational root. Here, move the 4 over. divide by 3, and take the square root, plus and minus the square root of 4/3. Now, anytime you're dealing with these, remember that you can split square roots. That's the square root of 4 on top, which we know, square root of 3 on bottom, which we don't know. When you rationalize that, let's multiply top and bottom by root 3. That'd be 2 root 3 over 3, which again are 2 irrational roots. So now let's combine what we've been doing with these methods that we've learned in the past, and let's find some rational roots. So we're using the rational zero theorem. We're doing the same thing we did in the last lesson. List all the possible rational zeros, then find the real zeros. And I'm going to go ahead and list all the possible rationals. So there's all the factors of 36, and then all the factors of 1 to be plus and minus 1. So here would be all your possible rational roots. Let's try to find one that works. And here I've tried 2, and 2 did work. It gave me a remainder of 0, so therefore I've broke it down. My new function, after I've factored it here, would be x minus 2, because I divided by 2, times, this is constant x squared, that'd be x squared minus 18. I can actually stop there. This will not break down any farther. Set each of these equal to 0, and you'll get x equals 2. However, x squared minus 18 equals 0. When you go to solve that, you will find your other 2 irrational roots. X will be plus and minus the square root of 18, which is x equals plus and minus, always simplify it, the square root of 9 times the square root of 2. So there are your 2 irrationals, and then you have 1 rational. Number 6, I'm going to list all of my possible rational roots first. So you see all the factors of 60 on top, which there are a bunch, over all the factors. Luckily, this is 1. So your possible rational roots are these. Again, test and try to find one of these values that work. That will probably take a while. Here you see that positive 4 was one of the ones that worked. I've broken my equation down now into this. You divided by 4, so x minus 4 would be your factor, and you had left x to the third plus 5x to the second minus 3x minus 15 is your new function. Anytime that you have the opportunity, always try to, if you have 4 terms, always try factoring by grouping, because that's going to be much faster. Factor in x squared out of the first group. I'm going to do brackets here, so you don't have 2 sets of parentheses. You're left with x plus 5. Factor in negative 3 out of the second group. You're also left with x plus 5. So therefore, factoring by grouping is going to speed this one up a lot. X minus 4 times, pull out the x plus 5, and you're left with x squared minus 3. Now, to find all of our zeros, we're going to set this equal to 0. We're going to find out that x is either equal to 4, negative 5, or we're going to set this equal to 0. X squared minus 3 is 0. Move the 3 over. Gives you x squared is 3. So your last 2 would be positive or negative root 3. There's 2 rationals and 2 irrationals. Number 7, same thing. List all your possible rational roots first. And there actually wasn't very many on this one. Next up, let's test them to find one that works. And here's where I use negative 3, and you can see how it worked. So we've now broken our function down into x plus 3 times x squared minus 8x minus 5. And the problem now is x squared minus 8x minus 5 will not factor. So therefore, we have to go to our other methods. And you can, the options were for a quadratic function, you can factor, which didn't work. You can use completing the square, or you can use the quadratic formula. And there is your quadratic formula if you don't remember it. Reminder that I always like to do the stuff under the discriminant first. So I'm going to take, and we'll actually solve it over here. So here is my actual problem that I'm solving. Here's b squared minus 4ac, which is again your discriminant. I got 64 minus negative 20, which you can add those together, and that's going to be 84. Again, that's the stuff under the radical in the formula. So I go ahead and put it under the radical. Again, I go ahead and simplify it. That's going to be the square root of 4 times the square root of 21, which is 2 root 21. Now that's got this whole part finished. Now the rest of it's easy. Plugging into the rest of the formula, you have negative b plus and minus that stuff divided by 2 times a, and the a value there is 1, so divided by 2. Clean that up, divide each of these values by 2, gives you 4 plus and minus the square root of 21. So that would be your other two roots. So you have x's of negative 3 or 4 plus and minus the square root of 21. There is the three roots, the three solutions to this equation. Number 8. Again, let's list all of our possible rational roots. And we see it's actually a very short list. So luckily, hopefully, we can find one pretty quick. Here is where 1 worked. So let's take our function and let's rewrite it. Since we divided by 1, our factor would be x minus 1. We're left with x squared plus 6x minus 19. And again, our options are quadratic formula, completing the square. And since we did quadratic formula on the last one, I'll remind you how to complete the square. So we're going to set each of these equal to 0. So my roots would be x equals, here would be 1. And to set this equal to 0 and solve it, let's come over to the side. And a reminder, right here, you can use that quadratic formula again, but here's completing the square. Move your constant term over to the other side. Leave yourself a space. Let's complete the square there. That'd be x squared plus 6x. I don't know why I rewrote that. Half your middle term, square it. Gives you 9. Whatever you add to one side, add to both sides. Factor it. That'll be an x plus 3 to the second equals 19 and 9 is 28. Now you're able to solve it. To get rid of a square, we're going to go to the other side and do plus and minus the square root. And that can be cleaned up. That'd be x plus 3 equals plus and minus 2 root 7. Last step, move the 3 over, and you have negative 3 plus and minus 2 root 7. That's going to be your other two roots. Negative 3 plus and minus 2 root 7. So again, you can use factoring, quadratic formula, or completing the square. Number 9, list all your possible rational roots. And there's the whole list. And again, numbers like 36 are pretty scary numbers whenever you're doing these problems. Let's try to find one that works. Okay, so we've tested negative 4, and it ended up with a remainder of 0. So therefore, x plus 4 must be a factor. So let's rewrite this. Our function is now, we divided by x plus 4, and we got x squared minus 3x minus 9. We're going to set each factor equal to 0, and we're going to have our roots are now negative 4. And again, the reason we're doing this right here does not factor again. So our other method is we can either complete the square, which is probably not a good idea when that middle term's a negative 3, or we can use our quadratic formula again. So here's our equation. Again, I always like to start out with b squared minus 4ac, which is your discriminant. B squared will be 9. Now let's do minus 4 times 1 times c, which would be 4 times 1 times negative 9, which is a negative 36. That's going to give you a minus minus is a plus. So the stuff under your radical is 45. And again, if you'd like to go ahead and put it under the radical, simplify it, that's 3 root 5. So now my formula says x is equal to negative b. Here's b. So negative negative 3 is 3 plus and minus that stuff over 2 times a. My a value is 1, so 2 times 1 is 2. So there is, since this will not divide, you don't have to split it. That's going to be my other two roots. 3 plus and minus 3 root 5 over 2. Okay, number 10. Last one. First, let's list all of our possible rational roots. And there they are. There are several this time because of the 3 here having 2 different factors. Let's test them to find one that works. And we see here that 6 does work. So we have now broken our function from the original into, we divided by 6, so x minus 6 times 3x squared minus 12x minus 1. And since we've done quadratic formula twice, I guess we can complete the square here. Let's set each factor equal to 0. So you'll get x is equal to, from here, x is equal to 6. And then now we've got to solve this. And again, I'll again use the method of completing the square just to remind you. And here we go. And the reason I really didn't want to, it's kind of scary anytime you see that number out in front of x squared. It makes these a little bit tougher. But step number 1, Let's move our minus 1 to the other side. And if there's ever a number in front, it has to be factored out before you start this. So this one won't be too bad though. So there's what you now have. Complete the square here. Take half of this, square it. You're going to add 4. However, you added 3 times 4 to that side, so add 3 times 4 or 12 to the other side as well. As soon as you complete the square, your next step is always to factor. There's what you now have. Let's get rid of the 3 by dividing. And let's get rid of the square by doing x minus 2 equals plus and minus the square root of 13 thirds. And I'm gonna go ahead and split that into the square root of 13 over the square root of 3. Move the 2 over, and you have x is equal to 2 plus and minus the square root of 13 over the square root of 3. Now that can be rationalized, and that's going to be the square root of 39 over 3. So you can leave it like that. So 2 plus and minus the square root of 39 over 3. Or you could do a common denominator, multiply top and bottom by 3, and you would get 6 plus and minus square root of 39 all over 3. So either one of those methods of leaving your answers would be fine.